Hello everyone, welcome back to the session. In our previous session we discussed about the various layers of atmosphere, in which we discussed about the density wise arrangement of layers in our atmosphere, which we used to call as troposphere, stratosphere, mesosphere, thermosphere, exosphere and ionosphere. So in our last video we discussed about ionosphere. I hope there is a clarity with respect to the role of ionosphere when it comes to the radio wave communication over the earth's surface. I hope you remember, with respect to the curvature of our earth, it is not possible, technically it is not possible to perform a visual communication with respect to the line of sight beyond a certain limit of distance, or let's say in kilometers. In order to facilitate beyond visual range, you can say, or without the line of sight hurdle, there can be a communication, and that communication is being facilitated by ionosphere. I hope there is a clarity with respect to that specific structure and composition of our atmosphere. Moving ahead with a new topic, and that is solar flare. See, this solar flare, this coronal mass ejection, then we have this solar winds and all. You will also learn about these things in science and tech as well, but we will be taking these topics with respect to the generalized overview of geography. So for the geography purposes, we will take a consideration of these aspects. So these topics, these aspects will be very much generalized. There is no need to go further deep as far as the civil services are concerned. Alright, so solar flare. Solar flare is basically a intense solar flare is basically a release of intense energy burst. Energy means there could be a X-rays, there could be a UV rays, there could be energy particles, charged particles, you can say. So whenever we have a sudden intense burst of energy, and like all the radiation which we used to found in our universe, all of them are actually the electromagnetic one. So when we have a electromagnetic radiation, or let's say electromagnetic charged particles, when they are released from the sun surface, so that will be called as what? Solar flare. And yes, it will cause, it is actually caused by the magnetic disturbance on the sun surface itself. Because of the magnetic some sort of anomaly, there is a releasing of what? There is a releasing of this high energy burst electromagnetic radiation, which we are giving a term here as solar flare. See, this solar flare would be produced whenever we have a two twisted lines. These two twisted lines, when they are there, so when these two twisted magnetic field lines on the sun surface, when they reconnect with each other, as a result of their reconnection, what will happen? Intense burst of energy will release, and this intense burst of energy will be termed as what? This intense burst of energy will be termed as flare. Okay, it will be known as what? Flare, solar flare. And yes, they will be a what? Bright flash. They will be a bright flash apart from the solar flare. And I told you this flare include what? This flare include X-rays, ultraviolet rays, visible light could also be there, and yes, we can have electrons, protons, or other charged particles. There could be alpha, beta particles as well with respect to this kind of interaction. Now, you might have heard about one more term, that is solar wind. Now, solar wind and solar flare are different from each other. Solar wind means what? Solar wind means what? Continuous stream of charged particles. There is a continuous stream from the sun surface. There is a continuous stream of charged particles usually, and that is being called as what? Solar wind. And some during some sort of cosmic events, we can have what? Solar flare. So solar flare is like you can consider in this way. Solar flare is like monsoon, and solar wind is what? It is occurring at any point of time. It is continuous, it is permanent in its occurrence. But solar flare is, we can say, less frequent with respect to the occurrence, and it will be occur when there is a two magnetic lines when they will twist it. But this solar wind will be continuous stream, and it will going to release from the sun's atmosphere, and it is continuous. So this one is continuous process, and this one is what? This one is like a frequent, and it is, we can say, non-permanent in their nature. It is what? Solar wind is permanent. It used to be there throughout the 24 hours, 7 days, 365 days you can consider. But the solar flare is rare with respect to the solar winds. Rare in the terms of, like, it could be there with respect to the twice, thrice, 5 times in a given year. But the solar wind will be continuous. Okay? Throughout the year it will be. So when it comes to this particular Earth atmosphere, so here you can see this is the sunspot, and when we have a two magnetic lines, so here you can see this is the charge streams of particles which is there. Now this is what being known as solar flare. So this is how the solar flare is there, and the solar flare will be moved towards the Earth, or let's say the atmosphere. And I hope you remember, with respect to the ionosphere, we have what? Charged particles there. So this solar flare, and yes, we have a continuous solar winds as well. I hope there is a clarity. I hope you can distinguish between the solar winds and solar flare. The solar flare is, we can say, a rare event. However, solar wind is what? A frequent event. It is less frequent, is more frequent. So when we have a two set of condition, let's say solar wind is there and solar flare both is there. So what will happen? They will going to interact with the magnetic field of our Earth. These charged particles will going to interact with the ionosphere, which is comprised of ultraviolet radiation, which is comprised of charged particles. I hope you remember. And as a result of this, some few activities will be visible on our Earth's surface. You will see that these activities will be known as what? Glowing sky in northern hemisphere and even in southernmost hemisphere, which we used to give name as Aurora australis and Aurora borealis. There is a glowing sky, especially in the polar parts of our Earth. So the reason of glowing sky on our Earth's surface is this: solar flare, and yes, we have a solar wind. So because of these two, we have a high energy particles. These high energy particles will interact with the ionosphere, and as a result of that, there is a glowing sky. Moving ahead. If you see the impact of solar flare, it's because of this solar flare or this solar storm, you can say. Because of this solar flare, it's because of this solar storm, there could be a huge impact on our Earth's surface, and we have seen this impact in terms of the blackouts. The power blackouts were observed once in the USA, and yes, parallel to that in Russia as well. It was because of the intense solar flare. So when there is an intense solar flare, there is an intense magnetic field. That intense magnetic field would going to change the behavior of metal objects that are found on our Earth's surface. So if there is a solar flare, as a result of the solar flare, first of all, what could happen? There could be a damage to the spacecraft. There would be a damage to spacecraft. There is a circuits, there are electronics, and if we have a high energy particles, if those high energy particles, if they are there, they will going to make the structure of those PCBs, printed circuit boards, those who are comprised of metals. Those metals will become unstable. As a result of that, the PCB will not going to work properly because of the solar flare, because of the high energy particles, UV rays, X-rays. So they will be what you can say damage to spacecraft electronics. And yes, if we have a satellites in orbit, those will also going to disrupt, and yes, there will be a hurdle in the communication. There will be hurdle in the communication with respect to the aviation industry, with respect to the GPS signal, yes, with respect to the internet as well. So there might be a problem. Power systems, we used to see the long cable network with respect to the power transmission. So if there is a solar flare, and if the solar flare is intense, so there will be a production of telluric current. There will be a production of what? Telluric currents, not in the pipelines only, but the telluric currents will also be produced in the electric wires, metal wires, which we used to see, especially with respect to the high tension voltage or high tension transmission networks if they are there. So because of the solar flare, their function would be affected, and as a result of that particular factor, what will happen? The power blackouts will be there. I hope you remember in your childhood you might have learned that we used to produce electricity by by rotating a coil between N and S. That is what the magnetic field. N and S, that is what the magnetic field. And when we rotate a coil, when we rotate a metallic coil in this magnetic field, there will be production of what? Electricity. Simple. Now here the solar flare which is there, the solar flare is what? The solar flare is electromagnetic radiation. So when we have a same magnetic radiation here on our Earth surface, the metallic objects, where it is railway track, whether it is, let's say, power lines, whether it is pipelines, whether we have a large aircraft or ships, as a result of this reverse electromagnetic magnetic fields, there will be some sort of functioning affect. The functions would be affected. Why? Because of the telluric current. Telluric current will be produced, and as a result of that, the power blackouts could be there. There could be a breakdown in internet. There could be a uh, hindrance with respect to the satellite communication and including the space electronics too. So the solar flare is posing immense threat to the Earth as well as to the space. Now we used to say the solar flare in terms of space weather. That whether the space weather is stable or not. So if there is a solar flare, if there is a solar storm, we used to say that if there is a solar flare or if there is a solar storm, we used to say that the space weather is unstable. If the solar flare is, let's say, if it is not present, then we will say that the celestial weather, or let's say the cosmos weather, or let's say the space weather is stable. Now, if we have a stable weather, that will going to facilitate the launching of rockets, satellites. If we want to carry out uh, these other planetary missions, those conditions will be favorable for such kind of launch if we have a stable weather events. If we have a stable space weather event. Solar flare, if it is there, that will not be a stable. So this is how they will. Let's have a deep dive on impacts.